We're barreling towards a future that's basically run by artificial intelligence. We're talking about an economy of autonomous agents, managing trillions of dollars. But this entire vision, it really all hinges on one single critical question. Think about this. By 2030, AI agents could be handling the vast majority of transactions on global networks. That's trillions and trillions of dollars in assets. But here's the problem. Their decision-making process is often a complete mystery. It's a black box. We can see the data that goes in, and we can see the decision that comes out, but the why? That's totally hidden. And if an AI is going to manage our money, we need to know for sure it's playing by the rules. That right there is the multi-trillion-dollar trust problem. Okay, let's break this down. On one hand, you've got today's AI. It's a black box. It's incredibly powerful, but we kind of have to take its results on faith. The future, though, is something else entirely. It's the verifiable agent, an AI that can actually prove it did what it was supposed to do, using some pretty slick cryptography, all without revealing its secret code. It's really the difference between blind trust and absolute mathematical certainty. So how do we get from here to there? Well, here's our roadmap. First, we're going to dig into the challenge of an AI-run economy. Then we'll uncover the cryptographic secret that makes it all possible. We'll look at where this tech is already up and running, see how it applies to AI, and finally, we'll explore what happens when AI becomes provably trustworthy. Right, so let's be crystal clear about the stakes. For an economy of autonomous agents to actually work, to buy data, settle payments, manage assets, without a human looking over its shoulder every second, we need an unbreakable way to verify their actions, to prove they're correct and haven't been messed with. And this brings us to the breakthrough solution. It's a cryptographic concept that seriously sounds like something out of a spy movie, but it's actually been in development since the 1980s, zero-knowledge proofs. So, what in the world is a zero-knowledge proof, or ZKP? Simply put, it's a way for me to prove to you that I know a secret, let's say a password or the solution to a really hard puzzle, without ever showing you the secret itself. You become 100% convinced that I know it, but you learn absolutely nothing about what that secret actually is. The classic way to wrap your head around this is the cave analogy. So picture a cave shaped like a ring. It's got two paths, A and B, and there's a locked door between them. Now you're the prover, and you have the secret key. You go down one of the paths at random. Your friend, the verifier, stays outside and yells, "Hey, come out of path A." Now, if you're already in path A, you just walk out. Easy. But if you're in path B, you just use your secret key, unlock the door, and walk out of A. Your friend never sees you use the key. You do this over and over, and eventually they'll be mathematically certain you have that key, but they will never, ever have learned the secret to opening the door themselves. What makes this whole thing so powerful are three mathematical guarantees. First is completeness, which just means that an honest proof will always be accepted. Then you've got soundness, which guarantees that a fake proof will always be rejected. You just can't cheat the system. And finally, zero knowledge. That's the magic ingredient. It guarantees the verifier learns absolutely nothing except that your claim is true. And look, this isn't just some abstract theory. Zero-knowledge proofs are already out there in the real world, securing billions of dollars and powering major applications today. ZKPs are the engine behind huge blockchain scaling projects like zkSync, which bundle up thousands of transactions and use a single proof to validate all of them. They're also used for financial privacy in cryptocurrencies like Zcash. Even huge companies like Visa are experimenting with them for private payments. And they're perfect for digital identity, proving you're over 21 without having to show your entire driver's license to a stranger. Okay, so we have this incredibly powerful tool for verifiable computation. The next logical step, then, is to point it directly at our original problem, the AI black box. And this is where a brand new field, zero-knowledge machine learning, enters the picture. ZKML is pretty much exactly what it sounds like. It lets an AI model make a decision, and then it generates a cryptographic proof that the decision was the honest result of its programming. It proves the model wasn't tampered with, that it processed the inputs correctly, all without ever revealing its secret sauce, the proprietary data, weights, and architecture that make it valuable. The tech that makes this possible is called a zero-knowledge virtual machine, or ZKVM. A normal VM, it takes in a program, runs it, and spits out an answer. You just have to trust it. But a ZKVM does something revolutionary. It gives you the output plus a cryptographic receipt, an unbreakable proof that the program was executed exactly as it was written. So what's actually in this receipt? Well, it has two key parts. The journal is the public output, That's the result of the computation that everyone can see. And then there's the seal. The seal is the ZKP itself. It's like a cryptographic notary stamp that proves the journal was produced by the correct program following all the rules. The seal is what makes the whole thing verifiable. All right, now we can connect all the dots. We have AIs that can literally prove they're being trustworthy. So what does this unlock? It unlocks the entire vision of the autonomous economic agent. This is the future we've been building towards, a network of interconnected AI agents, all operating on our behalf. And because every single action they take can be cryptographically verified, they can be trusted to handle high-stakes financial operations completely on their own, 24/7. Now, you might be thinking this all sounds incredibly expensive to run. But here's the kicker. Recent breakthroughs have driven the cost way down. We're talking about systems targeting costs of about 1/100th of a cent per transaction. At that price, a high-frequency machine-to-machine economy isn't just possible, it's pretty much inevitable. So, what can these agents actually do? Well, verifiable agents can settle payments across borders instantly, replacing entire old-school banking systems with pure cryptography. They can execute a private trading strategy while publishing a public proof of its integrity. They can manage collateral, tokenize assets, and operate around the clock without any risk of human error or hidden fraud. This isn't just a small improvement. It's the foundation for a whole new, much more efficient and trustworthy financial system. You know, we started this journey with a trust problem, a black box that we just couldn't rely on. But with zero-knowledge proofs, we can crack that box open, not by revealing its secrets, but by forcing it to prove its own integrity. This massive shift, from blind faith to verifiable truth, it changes everything. And it leaves us with one final thought. When machines can prove they're the most trustworthy actors in our economy, what new frontiers will we ask them to explore?